Hello and good morning. I'm Pravesh Jamgade, a PhD candidate at IIT Ropar. I'm working with Dr. TV Kalyan in Computer Science and Engineering Department at IIT Ropar. My broad subject of PhD is Computer Architecture. I joined the PhD since July 2022. Currently, I'm being funded by Institute Fellowship. I joined for the PhD program through GATE score. Through GATE score, I was able to give the interview process here at IIT Ropar. Uh, Before joining PhD, I graduated in 2018, and after that, I started working for a startup. And then I joined at IIT Ropar as a JRF for a SERB India funded project titled as Massive Graph Processing on General Purpose Computer. For motivation of my PhD, I have shared some slides. As you can see in the slide, it is the fastest supercomputers as of 2023 taken from the top 500 website. I have taken the Fugaku for an example. As you can see, Fugaku has around 0.15 million nodes, and per node there are 48 cores. And for these 48 cores, the shared L2 cache is around 8 MB. Now, as you can see on general purpose computer as well, there is a availability of 8 MB cache. Okay. So why did I presented this configuration is because see the graph size is around 2.1 gigabytes if you take an example of cron data set. Okay, so these are the benchmarks. The natural graphs could be more larger than this, and so the point was even on the supercomputers cache, we cannot fit the entire graph for processing in its on-chip caches, right? But it can be well fit into the permanent storage even on the general purpose computer, right? So what is the problem with the graph workloads is the larger working set size, as we already seen. And again, when we have larger working set size, then most of the accesses will have to go for the DRAM or the permanent storage. And because of the speed difference between CPU and the memory, so this is what we call the memory wall problem. Again, graph workloads exhibit a very irregular access pattern, and because of which the proper microarchitectural elements such as predictors or even prefetchers could not give the um, expected performance. And again, that goes for the larger working sets because of the larger working set. Also, there is a load to load dependency. That is, unless and until you execute one memory access instruction, you cannot execute the other because it is dependent on the first one. And that is why we have low memory level parallelism. Now, because the most of the accesses are going for the off chip memory, such as DRAM, uh, so because of the limited bandwidth of the DRAM, uh, we do not have we don't have the gain in the performance, and that's where we found our motivation of having a high density memory at last level cache. And currently, non volatile memory is the emerging technology that offers this advantage. Non volatile memory has faster read operations. It has low static power compared to SRAM. It has small area, and that's why we could move 4 times more data compared to the SRAM. But it has some disadvantage that forms the basis for our second and third objective. And the disadvantages are the costly write and the limited lifetime. So this is how we formulate our three problem statements. The first one is taking the graph big data applications into consideration. We wanted to take the advantage of non-volatile memory for processing of graph. Now, once we have decided to use the non-volatile memory at last level cache, then we have to solve the problems related to the non-volatile memory, such as the limited lifetime and the performance limitation because of the high write latency and the energy consumption because of the write operations. The third problem statement is related to the security because there is a limited lifetime of last level cache. There are possible wear out attacks on the on such memories, and we want to explore that too. So this is how our problem statement goes. The expected timeline is by the end of 2023, I've already finished my coursework and background studies related to the research, graphs and STT and non-volatile memory such as STT-MRAM. By the 2020 end of 2024, I am expected to do my research objective one and comprehensive. By By the end of 2025, I'm expected to do research objective 2 and TPS. And by 2026, I'm expected to wrap up my objective 3, synopsis and defense. Thank you.